Hello, everyone, and welcome to the session on a new approach to continuous monitoring in the cloud and the benefits of migrating to AWS with NETSCOUT. My name is Michael Segal. I'm the Area Vice President of Strategic Marketing, working very closely with AWS, both AWS Marketplace as well as AWS Partner Network.
Hi there, I'm Ray Krug. I'm a solutions architect for NETSCOUT, which means that I get all the fun. I get to play with all this stuff in AWS and take a look at performance and security monitoring. So that's the fun job that I get. And today I'm going to be helping Michael with some of the demonstrations that we'll be showing in this new approach. Over to you.
So with that, let's take a look at the agenda today. We'll start with some of the hybrid cloud migration challenges as you extend your on-premises environment into AWS. We'll take a look at the existing traditional solutions for monitoring and identify some of the shortcomings of these solutions. Then we'll discuss an alternative, new approach to continuous monitoring in hybrid cloud, and this is based on smart data. We will look into what is smart data, how it's generated, and the actionable insight that you can retrieve from this smart data. We will then go on and review with you several use cases from an international energy company and look at how this specific customer is implementing the solutions that we will discuss in real-life scenario. So with that, we are going to look first at the challenges. But before we actually start with the challenges, let's look at the sum of the initiatives that IT and DevSecOps teams are facing as they embark on the digital transformation journey. The key here is to innovate with confidence, and innovation is usually done through services. So as such, agility of delivering new services, continuous delivery and continuous deployment pipeline is critical to the success of this digital transformation. So typical initiatives would be AWS cloud migration, and as such, we will review in geographically distributed environments of this large energy company how this migration is being implemented. Another aspect of this migration are microservices, and we'll take a closer look at the microservices. Obviously, these are used to refactor or develop applications that are born natively in the cloud itself. The second initiative is continuous monitoring. Basically, you have established your governance and policies on-prem, and now you need to extend them to the cloud. So how do you extend this visibility and continuous monitoring for both performance of applications that are now running in hybrid cloud environment, as well as the security in terms of vulnerability and threats for those applications? And the third initiative is DevSecOps transformation. And this is based on common situational awareness, which means basically that collaboration is key to a successful DevSecOps operation. And what I mean by common situational awareness is that you have the right telemetry at the right time and effective feedback that enables the entire team, including development, Sec, Ops, QA, and management, to see the same situation through maybe different lenses and custom reports and respond effectively to assure continuous delivery velocity is maintained. So with these initiatives in mind, let's take a look at the hybrid cloud migration challenges. The first is which workloads to migrate. So some workloads on-prem can be tightly coupled with your infrastructure. You need to understand the dependencies of the application on network, on servers, on service enablers such as AAA, DHCP, DNS, and others, in order to assure, and obviously the databases, in order to assure that once it's migrated, it performs well. You also need to establish baseline performance to understand if the performance is adequate for your needs, and then compare this baseline to the performance of the applications that are now running in a hybrid cloud environment. The second one is how to assure application performance. Obviously, we are talking about digital transformation and assume that you innovate by delivering new services. But you need to assure a delightful customer experience in the process, which means that you need to monitor the performance of applications in hybrid cloud, and it all starts with visibility. You need to be able to instrument the workloads that you migrate to the cloud in an automated fashion and assure that you monitor their performance. The next one is obviously elastic scalability of AWS cloud is key consideration as you want to expand and scale up your services. And you also need to automate the process of instrumenting the new instances that you scale up or sometimes scale down in order to assure that you effectively assure this scalable environment. And last but not least, we discussed vulnerabilities and threats, and the continuous monitoring serves as a tool for you to also identify those threats to assure that your governance policies are implemented across the hybrid cloud. If we look at traditional approaches to continuous monitoring, these are based on domain-specific or domain-centric monitoring. So you have certain monitoring system that may monitor the server, the network, the application, the database, some of the service enablers that we discussed, such as a AAA server. At the same time, what is missing is visibility into the dependencies across domains. So basically, what is a service? A service is an application that is consuming some server processing resources. It's using database services. It's running on the network. It uses authentication, authorization, and accounting services, DHCP services to allocate IP addresses, DNS, etc. So all this together is a service. And this service is a complex system. And if you look at the service in terms of domains, basically you lose the bigger picture and you don't see the forest for the trees. Therefore, a new approach to continuous monitoring is required. And this new approach to continuous monitoring in hybrid cloud environment is based on smart data. But before we get ahead of ourselves, let's first define what is smart data. So smart data starts with wire data or traffic flows. If you monitor traffic flows, basically you have visibility into layer 2 through 7 in the ISO stack. You can see the data link, you can see the network, you can see the transport, you can see the session, you can see the application. What NETSCOUT does with Adaptive Service Intelligence technology, ASI technology, is performing deep packet inspection and using this inspection in order to generate metadata with key performance indicators for both application performance and security. And this data heuristically identifies the different applications so it can see not only the messages exchanged by the application, but also identified when there are errors in the application itself. It is software-centric, which means we will look as to how you instrument different environments, but it's very easy to instrument both physical and virtual and cloud environments with software-centric architecture. It offers cloud visibility, not only the traditional south-west, north-south, visibility, but also east-west visibility, which becomes very important when you think of VXLAN with 16 million virtual network IDs and the need to look into east-west traffic. It provides common situational awareness in terms of the ability to look at all the telemetry that is necessary for both application performance, network performance, and security, and gives this common situational view to all the different DevSecOps teams so they can collaborate and effectively resolve issues. And then last but not least, it can be exported for additional analysis using Kafka, REST APIs, JSON, and others. So all this is smart data. Now, let's take a look as to how this smart data is generated. vStream is one of the two products that I'll mention, and vStream enables to generate the smart data in hybrid cloud environments and provide basically what we refer to visibility without borders. The first example is the lightweight agent here, and it runs in an existing virtual machine or AMI. It sits on the same guest OS. It's very lightweight. It looks at the messaging between the application and the kernel, and this is how it basically retrieves what we refer to as wire data information. The second one is vStream that resides in a virtual machine. So it has more resources, more processing, more RAM, more storage resources, so it performs additional processing in terms of session analysis. It can store data in a smart fashion, only the most relevant data, and then effectively be used for both forensic analysis and back-in-time analysis. We are also partnering with VMware, and we are certified with the NSX solution, and also we are VMC ready. So VMware Cloud on AWS ready. So with that, for example, this specific vStream can sit in an NSX as the virtual service monitor and monitor a micro-segmented environment in which you have access to a different virtual machine. Last but not least, we have a container environment in which it can be Kubernetes or Docker-based environment, and the same vStream technology can reside in those environments, can be instrumented in swarms or clusters, and the specific nodes it can monitor based on the automated configuration. So with that, if you think of microservices that are fine-grained services that communicate through either RESTful APIs or some kind of messaging, such as Apache Kafka or RabbitMQ, this technology is best optimized to look at the wire data or communication between those loosely coupled services, and therefore it's very optimal technology to monitor microservices. So what we have seen so far is what is smart data, how it's being generated. Now let's take a look at the actionable insight that can be derived from this smart data with the nGenius-1 platform. And Ray, can you please illustrate some of the insight?
Yeah, sure, absolutely. So nGenius-1 is the platform that consumes that ASI smart data. And what can you do with it? Well, a load of stuff. Here's a couple of screenshots, or 16 screenshots, or whatever it is, to show you the various different workflows that we have within the nGenius-1 to help you triage and troubleshoot and optimize services that are running in the hybrid cloud environment. Starting off with the dashboard to give you a high-level overview of, let's say, the components, the areas, the regions of the applications where they reside, or, of course, the actual application components themselves, the services, the apps, the databases, etc. So you can tune that however you want to actually see the performance of that layer, as it were. Then, of course, you can use that to drill down into the service monitor, take a look into that layer, the VMs that are supporting that layer, and the performance. And as Michael was saying, in terms of performance, it's both application performance and network performance. We can distinguish between it being an app and a server problem because of that interaction over the wire, or whether it's a network problem because we're looking on the wire as well. So that's really important. So we can drill down into that and get that differentiator between app, network performance, and then deeper into the app to take a look at errors. We'll take a look at that in detail in some of the use cases I'll show you later on. Then we've got the service dependency map, which is the third one along there. That's discovery. Again, we'll look at that in more detail. But the idea is we're looking at that wire data. We're seeing the dependencies of the applications in the service. So whether it just be a web, app, and database, it'll also include those service enablers wherever they're located. Remember, visibility without borders. This could be a service that runs both on-prem and in the cloud. So we can actually use that dependency map to discover what's going on. Then, of course, there's a whole bunch of other discovery stuff that we can do, traffic discovery, link discovery, looking at the applications on both the physical network. Remember, in a hybrid environment, there's still going to be a physical environment as the on-prem hosts talk up into the clouds. It's going to go over a network. So seeing the performance of that network, traffic engineering that is really important. Bunch of other workflows like grids and reports. So they're all great to do your monthly reports, your SLA reports, et cetera, about the service performance. But of course, you might not want to be staring at dashboards, staring at reports all the time to see when things are going wrong. You want this to be an intelligent system. You want alerts. So we have alerts. We have baseline alerts, threshold alerts, which actually trigger based on deviations from the norm or thresholds, et cetera. We've also got deeper sort of machine learning algorithms in there, which look at cause and effect. It's not just looking at one metric and thresholds and baselines. It's looking at a bunch of them and correlating them together. Good example of that, servers slowing down because there's an increased number of transactions going to it at a certain time of the day. So we'll just bubble up those sort of analysis up to the top and alert you just on those particular situations. Bunch of security stuff, a couple I've got on there as well, certificate monitor. We're able to obviously see that wire data, we see the handshaking going on, and we can take a look at the ciphers going on, the certificates, whether they're using strong ciphers, weak ciphers, etc. More of that in the security session we'll talk towards the end. Threats, denial of service, attacks into your network. Again, we can detect those are going onto the network. So it becomes very much a performance and a security solution on the single pane of glass there. Finally, of course, it all boils down to, in a way, packet forensics. So the thing is, we don't throw away the packets. We use the wire data and the packets to do our analytics, our key performance metrics and our key security metrics. But we've also got the packets in our pocket. So when you want to do the forensics, you can reference those packets to give you the evidence as well.
So lots and lots of actionable insight, which can be overwhelming unless you have very simple workflows. And this is why NETSCOUT is introducing top-down workflows that enable you very quickly as 3 clicks, identify root cause of any challenges. So it's a top-down approach that is implemented within GeniusOne, and throughout the use cases, you will see consistently this approach being used again and again. It starts at the service dashboard, which basically enables you to see a 40,000 feet view of the different services and identify any service that has any kind of issues. You can then drill down immediately into the service monitor to look at load, latency, and errors associated with the specific service. If you need further, you can analyze the session, which is multi-hop communications between different workloads, and hop by hop identify exactly the messages exchanged and the errors associated with those messages. And last but not least, you can delve into the packet analysis, if necessary, in the context of what you have investigated. So you don't look at all the packets, you do look at the relevant packets that are associated with your workflow so far. So what we have covered so far is we discussed basically a couple of components of a solution for network application performance monitoring and also security assurance. And we mentioned vStream and GeniusOne. vStream is the device that generates the smart data, and GeniusOne is the analytics platform that gives you the actionable insight. So we are actually in marketplace. Our application management solution for AWS is in AWS Marketplace. It is comprised of all the same building blocks that I've discussed with CloudFormation template on top of it to automate the deployment. Please take a look at it and try it out. So with this, we want to move to the second part of the presentation and look at the use cases based on this International Energy Corporation. And let's start first, we mentioned the importance of instrumentation. So you start with on-prem, and now you extend your on-prem environment into AWS Cloud. How can you assure the visibility by instrumenting the new instances and workloads migrated to AWS Cloud? Can you demonstrate this?
Got it. So here we go. Here's an architecture map of exactly what you've described. And on the left there, we've got the on-prem deployment. So we've got the web servers, the app servers, maybe the enabling service, the shared services like Active Directory and DNS. So they're sitting on-prem. So that's all pretty cool. That was already instrumented with both the vStream and the Ingenious One. So they could actually use all those sort of workflows to discover what the performance was before the migration and also see the dependencies of those applications. So what that means, you know what to migrate. Then, of course, they migrated the applications, as you can see there, up into the cloud. They decided to actually put it into two regions, which was kind of regions closer to the users, in Asia and in Europe, as you can see from there, London and Singapore. So again, those workloads were migrated. So the app servers, web servers, and database servers were migrated, and you can see up in Singapore. At the same time they were migrated, they were instrumented. They were instrumented with the vStream technology that Michael talked about earlier on. So remember those lightweight agents that sit alongside the operating system looking at that east-west traffic or the north-south traffic coming in and out of those EC2 instances. So we get the wire data. We then translate that into smart data, push it into Ingenious One, as you can see in the diagram. So what we've got here is 3 Ingenious Ones, but you don't manage 3 Ingenious Ones. You manage it all through a single console, the global manager. That's the single point of entry for configuration, for discovery, for reporting, for dashboarding, for service dependency, and that allows us to bring this all into a single view, the hybrid view.
So Ray, we mentioned visibility without borders, and we distinguish between the domain-centric monitoring system and visibility without border as the ability to look at all the dependencies across the different domains. Can Ingenious One provide this visibility into the dependencies across domains?
Sure. Well, with smart data, of course, it's easy because we see the same smart data, whether it's generated in the cloud or whether it's generated on-prem, whether it's generated in a container environment or wherever it's generated. So here's our example of that same use case, that same architecture. On the left, we've got information about the connectivity in the data center. In the middle, in the AWS Singapore region. On the right there, the AWS London region. And you can see, and if we drill down a little bit bolder there, again, you might not be able to read it, but we see the communication between the service that sits in Singapore communicating obviously with its own database server also in Singapore. So we see that sort of interaction as well. But we also see interaction with Singapore here also talking to the back-end database, which they've not migrated, and that sits in the on-prem data center. But it's transparent to the user. You don't care where it is because you're seeing everything. More importantly about this diagram, it's not just about IP address A talking to IP address B. We're looking at that multidimensionally in terms of the application communicate between each of the, essentially the lines, the communication going on there. So, okay, we might have web traffic or REST traffic or API traffic in one link, but we're also seeing things like at the bottom there, DNS traffic. That DNS server, it's calling back to the on-prem DNS server in order to do its lookups. So to understand that, in the same way to understand that it's actually doing that long-haul access to that database sitting on-prem allows you to help you understand when it comes to a performance problem, my service is slow today. We're actually looking at whichever component is slow wherever it resides. And again, we're looking at that application latency and the network latency and the errors that the application's generating.
So this is, I think, a very important distinction, right, between just connectivity map and service dependency map. So when we say service, we look at the entire stack, all the way from the data link, all the way up to the application itself, including the enablers that you mentioned, et cetera, as opposed to connectivity based on IP addressing alone. So that's a big difference. Now, the other thing that we mentioned is the importance of continuous monitoring. And maybe you can demonstrate the workflow that we discussed, the top-down approach to continuous monitoring and the benefits.
Yeah, sure. So again, we both talked about this earlier, that 4-stage or 2-3 clicks to resolution. And it typically would start from that service dashboard. It's not the only mechanism that you would look at to actually start this workflow because, of course, we have the alerting that tells you that there's particular problems. But the dashboard, each tile there can represent the performance of a domain. AWS Singapore, AWS London, on-prem data center. It could also represent the performance of a particular application tier, the web tier, the app tier, a microservice tier, a database tier, the enabling tier, Active Directory, AAA stuff, and all that sort of thing. So in our case here, we've got the situation where users saying my performance is suffering. Okay, how do you know where to look? The forest from the trees scenario. So you'd use this sort of dashboard to actually take a look at, in this case, we're highlighting failures, and we're taking a look at one of the areas where we've got the most failures. And here we've got Singapore region AWS with a bunch of errors. And we can use that to then triage and go down deeper into the application that's residing in Singapore and take a look now. We're opening up Singapore, as it were, to the different tiers of the application that reside in Singapore. So that's the app layer, the web layer, the database layer here. And what we can see here pretty clearly is it's the web tier that's suffering. The users are coming in to Singapore on the web layer, and they're seeing a lot of failures, a lot of problems just by looking at the dashboard tile there. Remember, we can set these dashboard tiles to a huge amount of metrics that we have available to us, whether it's latency, application latency, network latency, or even down into particular errors. So we can actually use this as our triage point and then drill down into the next layer, which is the service monitor. So that's where we start looking and exposing those KPIs associated with that web tier, in this case, that web tier of that application. What we discover is that there's only one web server in this instance, and it's suffering. What we also discover here, if I just take a look at these graphs here, because again, it's difficult to read from a distance, is we're seeing performance over time in terms of number of transactions and the latency of those applications. And what we're noticing by this chart is as the number of transactions goes up, we're seeing the latency go up. That server is slowing down as it's getting more and more transactions. We can do this easily because we've got that ASI data. We're seeing the wire data. We're translating that into smart data, which is giving us that user experience perspective. So spikes of traffic reduces the performance of the service. And then if we look lower down here, we're taking a look at errors. So at the same time we're spiking with the number of transactions, we're also spiking with the number of errors as well. So there's a correlation here. What we've deduced on that second click, basically, is that server is underpowered for the number of transactions we're setting to it. It's all down through that smart data layer. What we can also do with that, of course, is drill down further and say, well, why is there that spike of transactions? Who's using that server? Why is it going up? And then we can open up what we call a community view, which shows you the clients that are trying to access that. So we've got that web server, we've got Boston users, we've got Bangkok users, Taiwan users, Singapore clients, of course, why not? But we've also got kind of a rogue client there, one that's undefined on that 144 network. It's something that we didn't plan for. It's something that we've discovered, because there's no name to it. We've discovered it, and it's sort of either a bit suspicious or lack of planning. We didn't expect those users to come online at that time and then generate those increased number of transactions, or it was just a mistake, or we just didn't size this server adequately. Of course, it's in AWS, so we can elastically scale it and do whatever we want with that server to make it perform better. More of that later. But in terms of taking a look now at this interaction between this new client group, we can go that next layer down to the session view. And when we look at the session view, we're now looking at effectively individual transactions from that client to those servers, looking at what URL is it accessing, if it was a database, what database is it accessing, what is it trying to do. If it's an API, we'll see what API it's accessing. In this case, it's HTTP GET. We're seeing that 501 error, and we're seeing the detailed ladder diagram of the performance of that particular error as well. We've got that very granular, and we can go even further down to packets to actually see the detail there. Remember, we don't throw away the packets. We use them to generate our smart data. We keep them stored, so we've got them for reference later. I think one of the important things about this use case, and I've shown you those 4 screens deliberately to get you down to that layer, because we've got the detail, but in reality, we solved this problem on the second click when we looked at that server performing slowly because of that increased number of transactions and the error. We've actually already knew what was going on. This is just extra detail and evidence.
Right, so basically you demonstrated a very straightforward top-down approach to continuous monitoring.
Absolutely.
Right, you started with the dashboard, immediately identified that the problem is in the Singapore with web services. You then drill down into the service monitor and saw correlation between latency and errors. You then, based on that, you drill down again, everything in context, into the session and looked at the transaction exchange. You also identified a rogue community of users that you didn't recognize in the process. And then, for good measure, you logged into the packet analysis for forensic analysis or additional analysis. So that's great. So now that we have identified the benefit of continuous monitoring, let's move into how we actually growing our AWS visibility as we scale up or down with the number of instances in AWS cloud. So the first question is when do we, or how do we know if we need to scale up the number of instances? And also, once we do that, after that, how we assure automated fashion of instrumenting that visibility. So maybe you can start by demonstrating another workflow that illustrates the fact that you actually need to scale up the number of instances in AWS cloud.
Yeah, I mean, that's where it gets really quite exciting, actually, because we give you the view, almost the end-user performance view. So we're looking at the performance of that particular application. And here's basically a different view of that dashboard where we're looking at essentially that latency. So think of it as you don't have to wait for the users to complain that it's slow. This is obviously the latency of all those transactions to the service. So it's balanced. It's the real-time traffic of what's going on to that server. In this particular example, we can see here, this is the latency figure here, and it's running at around 140 milliseconds. Now, okay, so we know that, right? And that's the one server example, and that's pretty high, because what we've set as our threshold is about 40 milliseconds. So we know that's way over. The server is slowing down because of those increased number of transactions. It's not good enough. So that gives us, in a way, our baseline, that we're seeing the performance of those servers. We're also seeing on the other side here a percentage of errors that are going on, and where it's red, there's errors. Where it's green, there's no errors. So remember those 500 errors that we saw earlier on. So we're seeing high latency, we're seeing errors, and of course, as you saw previously, we've seen and identified through that service monitor the detail of the errors themselves. So we've now got the baseline. One server, this is what's going on.
Okay, so we see that the latency is high and errors are high, way above the threshold that we defined for ourselves. So it seems as if it is time to scale up. Now, as you scale up the number of instances, how do you assure automated instrumentation of those instances?
Yeah, well, let's blow up the diagram again. That's what it was before, if you remember. So in Singapore region, what we really want to do is use auto-scaling groups, launch configurations, a load balancer to actually build from just one server to multiple servers and make that really easy. So each of those servers, remember, needs that vStream on it in order to record that wire data and translate it into smart data. So what we want to do is, as we scale up in our launch configuration, we want to automatically install that vStream. So that's easy. So there's a number of ways we can do it in Amazon, because that's terrific, the options that we get given. The obvious one is to just pre-install it into the AMI. So when the launch configuration kicks off, it's already got the vStream installed. It starts up, automatically registers itself to the nGenius One, so it's automatically sending its smart data to nGenius One, so you're seeing it. So whenever a new EC2 instance comes up, it's automatically instrumented, as it were. So we can keep on doing it and scaling that up automatically. Other ways of doing it, of course, is you might not want to pre-install it in the AMI for whatever reason. You might want to get an automated install after the launch. That's what user data is for. You can put a script in to automatically install that vStream into that AMI and get it to register to the nGenius One. Other methods that we've seen happen is CloudWatch triggers. So autoscale groups, new sessions instantiated causes a trigger in CloudWatch, which could then do a trigger to Ansible to automatically install that vStream into that agent, so into that VM. So there's a lot of ways to do this, and it's pretty slick because it just installs.
Okay, so can you go to the next slide and basically illustrate how do you provision it in the system?
Sure thing. So in reality, of course, if I want to scale up, I can do this manually. So this is like an Amazon screen where I'm changing my desired from 1 to 2, as an example. So that will automatically trigger an instance to be fired off, as we've just described, and instantiated. So in one of the 3 ways, the vStream gets installed and automatically registers itself to nGenius One. What that means is now when we look at our service dependency map, which we've discovered based on the fact that there's now a new server up and running, because the load balancer now has taken care, it knows about that new EC2 instance, it's sending the data to both EC2 instances. So we're actually seeing now the two web servers sitting there serving the application. So I've simplified the screen to make it a bit clearer for the demonstration. And then what's interesting about that is, remember our latency diagram from earlier on. So we're seeing this in real time. So in a way, as those servers are getting instantiated, we start now to be monitoring all the traffic to that load balancer, and we're starting to see the latency drop right down. So there it was at 140, did I say? Now it's dropped right down to about 70. So obviously, the improvements of the service is getting better. It's getting faster. So we're not quite there yet, because we want to have our threshold breached, so we actually get it to that performance. But what we're doing here is we're being able to tune or optimize our environment now based on the performance of the application. So this is different than, let's say, what Amazon will let you do when it scales up automatically, like looks at CPU utilization and says that triggers off a new instance, or look at number of transactions and that triggers off a new instance. This is kind of independent from that, because we're looking at the real-life responsiveness of that app. So we're seeing the real user experience of what's going on. So we're not there yet, but we're getting there in terms of performance.
So we see that the latency is improving, but it's still above the threshold right here. So it's now at 75 milliseconds, and the threshold is 40 milliseconds. We also see that the additional server was automatically discovered by the service dependency map, right?
Yeah.
It was not configured by you. It was automatically discovered. So obviously, we need to scale up even more. So how do we know how much do we need to scale up to meet the threshold requirements?
Well, you know, it's just a repeat of the same again. So I've just scaled this up, changed my desired to 8 in this case. So now we've discovered 8 servers going on there. But for the exciting bit, what's the performance like? So again, now we see that chart. We're now just dramatically below our threshold. So we kind of know it works. We know that auto-scaling works. We know that we get the new servers instantiated. We know that the load balancing is balancing the load to those servers, and we know now that that service is to specification. It's what we want at that time of the day based on that number of transactions. We're seeing also that the errors have also disappeared as well, which is kind of cool as well. So that's a fact that the servers now are really able to cope with what's going on.
This is great. So basically what we've illustrated, first of all, we identified the baseline of performance and the need to scale up. We automated the instrumentation of the new instances as you scale up. We define how much we need to scale up in order to meet performance requirements. And now we have accomplished this objective. So
one other point, actually, I was thinking about as well is if we then suddenly put on our additional users onto this system. Okay, so the net result of that would put more load on those individual EC2 instances. That would reduce the performance. But because we've got this continuous monitoring, we see when it will breach that threshold, we can then just add another one. And then another time of the day, maybe it's midnight when everybody's asleep. Not in Vegas, of course. But at midnight, maybe there's fewer transactions so that you know that you could decommission, delete, terminate those EC2 instances and get back the performance associated with and optimize what EC2 instances you're using.
And this is why we talk about continuous monitoring, because everything changes constantly.
Absolutely.
Right? So with that, what we have covered so far is what is smart data, and we illustrated that the key performance indicators for the smart data can provide actionable insight, both for application performance, network performance, as well as security assurance. So can you demonstrate a couple of examples in which the smart data provides insight into the security assurance?
Sure thing. So normally with security, I kind of divide it into 3 segments: threat analysis and detection, security operations, and behavior analysis. So that's the sort of things that we can do with wire data and smart data associated with that. Think of threat detection as attacks into the environment, trying to slow down or break your EC2 instances. DDoS attacks is a classic example of that can get through and attack your system. So I'll give you a use case of that in a minute. The other one is exfiltration, the idea of sending data out of your network effectively to known bad reputation sites. That's exfiltration, typically on DNS. Or the alternative might be kill switch. So with WannaCry, of course, we had the DNS domain, which was a kill switch. So if we're detecting that going on in the infrastructure, then that gives us visibility of those threats within your, or those security issues within your environment. The third area of that is, of course, once you've detected the threat, is to do the forensics, to get effectively down to the packets, the IP addresses that are the cause and the effect of what's going on. So again, remember, we've got that wire data, we've got that all stored, we've got that indexed, really readily accessible, so we can get access to those packets and do the forensics. Secondly, security operations, and I like to think of this in a way as a configuration management for certificates analysis as an example, taking a look at what's going on in the network, which is the real world. So if you think about it, you might have a configuration database of when your certificates are about to expire and all that sort of thing, and it may or may not be up to date. What we do with wire data and smart data is see what's actually going on in your infrastructure. We see whether they're using expired certificates or days to expiry. We see what handshaking is being done, whether it's old, weaker ciphers being used in your infrastructure, self-certified certificates, which is bad practice. So we see all of that, and it's real. Because the problem with certificates, if they're out of date or weak ciphers, then either your application stops working, or, of course, you're vulnerable to somebody trying to break your encryption. Thirdly, behavior analysis. I suppose think of that in terms of what's normal to your infrastructure. All these hosts communicate with each other on this port, and then suddenly there's a new host that arrives communicating on another port to these hosts. That's different behavior. Something's weird going on in the network that I'm not expecting. That we can detect. Other things are like brute force attacks, where somebody's trying to constantly access a server and failing the login. So if you start detecting that sort of activity going to the infrastructure, you know something is amiss. The other one, of course, is unusual protocols that you're seeing. And when I say unusual protocols, things that you weren't expecting. So remember, we're seeing all the wire data, we're seeing everything. A good example might be looking at SMB1 on your network. That's weak as far as a Microsoft protocol, and it was exposed when the WannaCry, I'll go back to WannaCry again, used it to actually replicate itself over the network. So if you see that going on in your network, it's a weaker protocol, and people can do bad things with it. So in terms of a couple of use cases I wanted to just show you and bring up here, in terms of threat analysis, remember these are attacks trying to slow down or break systems in your environment, wherever that might be. They could be volumetric, state exhaustion, application attacks, which is just trying to just hit a server and slow it down. My example here is DNS amplification, which we've detected in this case. And that's kind of an attack where the attacker spoofs an address which he wants to attack into your network, does a small DNS request on your DNS server, which sends out a massive request out to the server that you want to attack. Sort of an amplification. So a very small packet coming in generates a huge packet going out, hitting your servers. You do that a lot of times, you slow down the server, and it's an easy attack. So you've got to have a way of identifying that's going on in your infrastructure. Once you identify it, get to the forensics, the packets. In this example here, you can start to say, I've got to block that traffic because it's doing harm to my infrastructure. So it's kind of easy for us to do because we've got that wire data, we've got the smart data to detect it. It's easy for us to do, but that's because we've got this smart data. So that's a threat coming in, an example there where we can actually drill down and see what's going on. And then, of course, in terms of certificate analysis, remember I was saying we're seeing the wire data, we're seeing the handshaking, not only from the user layer to a web server, for example, we're also seeing the apps. The apps are talking to each other as well. And what's quite common is that you upgrade an app component, and then suddenly your application stops working, not because of any other reason than you're not using the right ciphers on the actual server itself because the old part of the app doesn't support the new ciphers or vice versa. So things break. So our certificate monitor gives you a list of all those servers, gives you the days to expiry of that certificate, and that's often a surprise to people. I mean, our discovery capabilities with these sort of technologies is amazing because I find that people will implement this sort of thing in proof of concepts, and they'll say, oh, I didn't know that server exists, or I didn't realize we were using weak ciphers, or in this case, I didn't realize these certificates were out of date. I didn't realize we were using self-signed certificates for these applications. It's bad practice. You don't really want to do that. Other ones, of course, is what are my ciphers that I'm using? Am I using weaker SSL3 instead of TLS 1.2? We can see what's going on. We can easily remediate that and make sure your application stays up and running.
Right. So these are a few examples of how smart data can help with threat and vulnerability monitoring. The other part of smart data, beyond what we discussed so far, is that NETSCOUT actually monitors 1/3 of the overall internet traffic, and it analyzes the threats that traverse the internet before they actually hit the customers. So that enables us to magnify the benefits of smart data for threat and vulnerability monitoring. So with this, we want to wrap up. And basically, at the beginning, we illustrated 3 key initiatives that IT and DevSecOps organizations are undergoing as part of the digital transformation. The first one is AWS cloud migration. So what we have demonstrated is that with NETSCOUT, you get end-to-end visibility, or visibility without borders, into this hybrid cloud environment. We also illustrated the fact that when microservices is used, it is most effective to monitor the communications, the messages between the microservices in order to understand the real performance of those microservices, and therefore the wire data approach is very effective in monitoring microservices. We then discussed the benefits of continuous monitoring. We illustrated the top-down approach for performance monitoring, and then demonstrated threat and vulnerability monitoring based on the same smart data. And last but not least, we've illustrated how common situational awareness can help with the DevSecOps transformation by giving them the right telemetry at the right time and offering feedback to the entire team, including the dev, the sec, the ops, the QA, and the management. So the last slide is actually several testimonials from our customers. So let's see what our customers are saying. Henry Ford Healthcare Systems, providing a testament to the fact that the continuous monitoring is proactive. Indeed, what you have seen is the very efficient top-down workflows that enable you to identify the root cause of service degradations and resolve them before customers are impacted within 3 clicks of a mouse. And that's why Henry Ford Healthcare Systems says that identify precursor situations is very efficient with NETSCOUT. The second one talks about the common situational awareness. We saw that the traditional approach to continuous monitoring with domain-centric monitoring system has a challenge because you don't see the forest for the trees, you don't see the service dependencies. Well, with NETSCOUT, you see both the forest and the trees. And same testimonial comes from Royal Caribbean, who use the NETSCOUT platform for both application and network performance management. And last but not least is Neotel Liquid Telecom, who basically says the bottom line is that with NETSCOUT Service Assurance, there is a delightful customer experience which enables stickiness of their services to their customers. So with that, I want to thank you for spending the last 50 minutes with us. You have my and Ray's email addresses. Feel free to send us an email with additional questions. We also have about 11 minutes left, and we want to open the floor to questions if you have questions, and we'll also stay after the session as well. Anyone have questions? I cannot see, that's why it's yes, please. Can you come, if you don't mind, and speak to the...
Oh, right,
the context
okay.
slide.
I see what you mean.
Okay, so Ray and I will stay here for another 10 minutes. Feel free to stop by.
Thank
you very much.
Thanks.